Hi guys, good afternoon. Thanks for watching my videos. This video builds upon two previous videos I made. First, I had made a video on a digital potentiometer module, which I have since put into a little hobby box. And I also made this 555 timer sound oscillator. And in those two previous videos, I was talking about controlling everything through the use of a microcontroller. Well, before I started experimenting with the Arduino, I was trying to make things happen with MPLAB in assembly language, and my skills aren't so great. So I was struggling, and a first attempt at a video failed after problems with me knowing assembly language. So, as a compromise, I decided to use my Arduino, and thanks to the C language, I can make this happen a little bit more quickly and easily. Alright, so just to review, even for my own sake, this is the digital potentiometer pinout mode selection diagram. More or less, this is what I'm trying to program with the Arduino. And hooked up to this digital potentiometer is a sound generator. So I'm using the paint program here. So this is the wiper up and down select, and it's two methods that are not really recommended, and I won't be using those. So just to make things simpler, I'll just delete that. On the back of the kit, I hooked up some external circuitry, and I'm holding the increment pin high with a 10 kilo ohm resistor, and I'm holding this CS pin low with a 10 kilo ohm resistor as well. So that's a pull down resistor I have on this pin and a pull up resistor. Yes, this particular pin is used to store a resistance value internally inside of the digital potentiometer chip, and that is done in this mode here. But this pin, as I got playing around with the digital potentiometer, I realized that this pin isn't merely just for storing the wiper position. Supposing you have the microcontroller hooked up to this and you're sweeping up and down. If you want to pause the sweeping up and down, all you have to do is send a high onto the CS pin, and it will suspend the wiping up and the wiping down of the up-down select. So I will turn now to an Arduino sketch that I wrote, and it makes use of these pins. So even for my own sake, I will read through this methodically. It helps me later when I need to review. So I created some variables, const int, and I created 3 variables for the 3 buttons, or the 3 digital potentiometer pins I'm using. The up-down select pin equals 7, pin 7. The increment pin is pin 13. I thought that was kind of neat because I can see the LED, which is hooked up on the Arduino. I can see that pulsing, so visibly I can see the increment pin doing its thing. And I also set this up to have an input pin on the Arduino, and that will come into play when I talk about some of the if statements. And I created some delay times, which I've experimented and played around with these numbers a little bit. And, well, the shortest delay time is 5 milliseconds, and I'll get to that in a moment. So, as my void setup, I set up the up-down select pin and the increment pin as outputs. So the increment pin and the up-down select pin are both outputs. And once again, those two outputs will send signals to the digital potentiometer and make it do something interesting, sweep through the resistance values. And this input pin is an input. So to begin with, I thought I would send the up-down select pin low and the increment pin high, because the increment pin actually is triggered by a falling edge. So if I just hold it high, it's not doing anything. That's kind of the resting state. And the resting state I have sent down to the low end of the resistance, or the wiper pins. And I'm still in the void setup here. So I thought, one time, right at the beginning of the code, as it's iterating through, I will just make the wiper on the digital potentiometer bottom out, go right down low. And I decided to use a for loop for that. Now in the digital potentiometer there are an array of transistors that will actually cycle through the different resistance values. Probably MOSFET transistors, I think I read that. But anyway, I just wanted to start at the bottom. So what this does, for more than 100 times, because there's 100 gates, I just went a little above. So I went to 110. So I'm going to pulse the increment pin 110 times while the up-down select is low. And that'll just plunge the resistance values right down. And then you can even hear that on the sound generator, the Mr. Noisy. And you can hear that when I reset the Arduino, it'll just plunge down really quickly. And the delay time there I set to 5 milliseconds. So it just kind of dive bombs right down. You can hear that when I reset the Arduino. And then I just have very simple if statements, and if the input pin is sent high, then the up-down select will go high, and with a delay time of like 15 milliseconds currently I have set it at, it'll ascend, and even the tone will ascend up through the resistance values. And if I put that input pin low, it'll descend as fast at 15 milliseconds I currently have it set at. So hopefully that explains it. And now I'm going to move over to, well, not breadboard, but my setup of circuits. Again, here is the setup. I'm going to mount my phone on a stand. I've got a 5-volt regulator powering everything, an op amp. Here's the sound generator. This is just being used to turn some signals up and down, particularly the input pin on the Arduino that I set up. This is the digital potentiometer box. Yeah, so it's pretty straightforward. So this is a headphone warning because I'm about to turn on the op amp and it's loud. I'll put a little cover on it so it's a little less loud. So it's currently at the top. It's currently at the top, and just when I hit the reset button, you'll be able to hear it plunge down very quickly because of some short delay times in the void setup, and it'll just plunge right down to the bottom.
So it's hard to tell. It's hard to tell what's really going on here, but I have the input pin, this orange line, and it's selecting the highs or lows. And depending on that, it'll make the tone ascend or descend. Now, what I can also do is this is the CS pin. And initially, I just thought the CS pin was used for storing that resistance value in the non-volatile memory. But actually, it's used for more than that. Because if you set the CS pin high while the wiper is sweeping up and down, you can actually pause on a resistance value. You can pause on a tone, and I'll try and show that now here. Yeah, so the CS pin is set up here on this white line. So the CS pin kind of suspends the sweeping up and down.